thinking about how they deal with manufacturing. And country like the Netherlands is no different from any other part of the world. They realize that there is a need to increase the amount of manufacturing that is done in a more local manner, and to try and deal with that in a way that it meets the demands and requirements of society. So I'd like to just share with you a little bit about our experiences in the Netherlands around trying to develop a new advanced manufacturing center. Maybe some of those experiences could be beneficial to other parts of the world, including Indonesia. So this is really the purpose of my presentation. I'd really like to thank you for the invitation to present this, by the way, and I really applaud you on putting this conference together. My name is Ian Gibson. I work at the University of Twente. I'm a professor there, but I'm also director of the Advanced Manufacturing Center, which is a patient platform for advanced manufacturing at the University of Twente. So this is a new facility. In fact, it's not completed yet. I'm just going to take you through some of the rationale behind it, and also to give you an idea of what you might expect in the near future. Basically, the Fraunhofer Innovation Platform is a facility that allows us to transfer research knowledge from universities, in this case, the University of Twente in the Netherlands, into more practical uses within the industry. From our point of view, we look particularly at small to medium scale enterprises and manufacturing industry in particular. Some of you might be familiar with the Fraunhofer network and thinking that it's a German entity. Well, yes, it is. Most of the Fraunhofer centers and institutes are located in Germany, but more and more of them are located around the world. And in fact, as you can see there, there's also a Fraunhofer in Jakarta in Indonesia. I don't know if there's at this conference. We are the first Fraunhofer center to be located in the Netherlands. We are in the eastern side of the Netherlands, very much on the very close to the German border. We work particularly alongside the Institute for Production Technologies, which is in Aachen in Germany. And we, as I said, really are aiming to address the needs of local manufacturing industry with advanced manufacturing solutions. Just to give you a bit of oversight on what is the Fraunhofer system, all Fraunhofer centers must be connected to a university. And in fact, in our case, the Fraunhofer Center is in fact an entity of the university. So I am a university employee. All of my research engineers, all of my staff are University of Twente employees. We use the Fraunhofer basically as the method of working, and also to connect through to the larger Fraunhofer network. We are relatively small and relatively new. A lot of Fraunhofers are 40, 50 years old or more. We are just 5 years old, just been founded in 2017, going through a route of development, increasing our amounts of activity, increasing our staff numbers, over a period of 5 years, to a stable point, which we are at the moment, with sustainable growth, and with a model that we are now very comfortable with, looking at the advanced manufacturing arena, and developing into this next stage, which is for creating our own facilities, which is the Advanced Manufacturing Center. This is really what I wanted to talk about in particular. We work alongside a lot of other centers within the university. A lot of these are what we call low TRL level institutes, i.e. looking at fundamental research in a variety of different areas, all technologically focused, because University of Twente is a technical university. What we do is we provide a channel to increase the TRL, the technology readiness levels, so that they can be more appropriately applied within industry. So there's a lot of knowledge and experience from my colleagues in all of these other centers that we can tap into and make good use of to solve these more immediate problems that industry are facing with their extensive knowledge and experience. Our vision is to basically become a leading applied research facility for advanced manufacturing within the Netherlands. We are really making great steps towards achieving that vision, and very happy to be part of the overall network of field labs and other facilities within the country, so that we can all work together towards achieving a better manufacturing environment in the nation. We do that through a very collaborative approach. So our mission is really also very much based around training our research engineers and giving them the experiences and the challenges and opportunities to develop and therefore take their place in industry and other related institutions to improve the overall quality of what we do within the Netherlands. Just to give you some insight as to where we are at the moment, we've have steady growth in industrial research projects. Our funding is based around project-based activity. All of our research funding is aimed at helping industry, and therefore there's always an industrial partner within anything we do, and also industrial contributions correspondingly. The Advanced Manufacturing Center is the next phase in what we are doing, allowing us to have 1,000 square meters of shop floor operating space. So our funding is in a variety of different ways in terms of infrastructural funding, which allows us to provide facilities and technology which we can then apply to industry needs, alongside the project funding, which is looking at specific problems. One thing to notice here, very much related to this conference, is that all European funding requires adherence to sustainability goals. So a very large portion of what we do is looking at improving the overall efficiencies of manufacturing, so that we can reduce energy consumption levels, material consumption levels, and make not just aimed at reducing costs, but also being able to produce a sustainable output. We do this in a variety of different domains, some of which are very overlapping. Manufacturing systems, for example, could relate to anything, but a lot of that is actually related to sustainability goals. We have a lot of activity in artificial intelligence. This is a lot of interest from industry in the region, looking at how AI can help them deal with the huge and ever increasing amounts of data that are becoming available to them, and making good use of it so that they can extract appropriate knowledge from that data. My background is additive manufacturing, and this is a technology which is very much aimed at creating agile industrial manufacturing solutions, being able to adapt to ever-increasing changes in demand, personalization, supply chain issues, etc. Computer-aided engineering is a critical component of just about any high TRL level research, basically looking at numerical analysis and also then essentially providing digital overviews and understanding of what we are doing or what these processes are actually achieving. And therefore, digital twinning is also a very critical component of what we do. So this is how we interface with industry. We also do that from the perspective of what type of projects. Well, a good project, best type of project is one that we are working just directly with industry, where industry pays for our work and results. But then there are quite a lot of subsidy type programs as well, which allow industry to reduce their costs and look at more generic solutions which are suitable for all sorts of industries. We do that also. There's a lot of knowledge transfer in what we do in terms of auditing, seminars and workshops, gathering information about the region, etc., etc. So going on to the Advanced Manufacturing Center, this now is going to provide us with the capability to not just look at what is going on at a company's shop floor activities, but also to demonstrate some of these concepts on our own, and therefore experiment a little bit about what might be good solutions for industry. So this can look at, say, for example, we can see what might happen if with changing market situations. We can look at how digitalization can provide you with better insight into your manufacturing processes, and then look at specific challenges and test those challenges on our shop floor ourselves. And then also potentially looking at maybe spin-out type of solutions which can be applied on a more general basis nationally and internationally. So just give you an idea of where we are at the moment. This picture at the top right was taken yesterday evening to sort of say, well, we've got a building and it's nearing completion. Due date for completion is December this year. So we will hopefully be in room for business, if you like, with the equipment in there by the early stages of next year. The shop floor, as you can see, is at the bottom right there. This is also a recent image showing the current status of our facilities. We already have funding to look at a number of demonstrators and create those demonstrators on our shop floor. Some of this will be looking at, well, what might happen if you have a 5G environment. There's a lot of people interested in how 5G and maybe even 6G can be beneficial to a manufacturing arena. So we're building a baseline structure there for information handling, but then also looking at more specific types of solutions. While 3D printing is becoming more and more popular, but then one of the things that we want to look at is how can you then create a manufacturing process chain from all of that. It's not about prototyping, it's about manufacturing using 3D printing technology, which requires therefore other processes, finishing processes, maybe assembly processes, material handling, etc. A lot of which may involve robotics. So this is a schematic of one of the demonstrators that we will be creating. The second one is based around battery technology. Technology, or sort of these types of energy technologies are becoming more and more critical around for many more and more products. So we are looking at how can we demonstrate an adaptable assembly process for battery packs for different types of battery-driven products, say hand tools, power banks, power supplies for electric bicycles, etc. So when a new product comes in, how easy is it for you to then change to suit this new product and integrate it into your overall manufacturing process? So we want to demonstrate this, all of which will be backed up by digital models to allow us to demonstrate how we can get the best information from the manufacturing system and relay that to the users to get them operating at a most efficient manner. Just to give you some ideas, a lot of these companies you won't be familiar with. They're very much localized, but some of them you will. So just to say that we've been working with a large number of companies, an increasing number, all of different levels, some very large companies, some small, and taking our place in the overall network of industry support and research centers for the Netherlands. And just to give you a final step, this is my last slide. Really, why is it important that we have something like the Fraunhofer Innovation Platform and the Advanced Manufacturing Center? Well, a lot of companies don't have the capability to provide or do this on their own. Particularly SMEs, they have limited budgets, etc. Although we also have the expertise. We have a lot of knowledge that we can tap into through the Fraunhofer network and the university networks, a lot of expertise, which should be applied to industry, as well as furthering knowledge at a more fundamental level. So I think that's about right for me. I thank you very much for your attention, and good luck with the rest of your conference.
Yeah, thank you, Professor Ian Gibson. And I would like to give you a chance to ask a question for the attendees. Is there any question? If no, I think we should proceed to show our token of gratitude for your participation. Please display the award. Please wait for a while, Professor.
I saw something.
Okay, I think we have technical difficulties for displaying the award video. Once again, thank you, Professor Ian Gibson, for your presentation. And I would like to carry on to the next presenter. Okay, I think Dr. Ilham Habibi is already with us. Okay, Assalamualaikum, Dr. Ilham Habibi.
Waalaikumsalam, dear moderator. Good day from Jakarta to Batam, I believe, or Bintan, right? Bintan, I think.
Yes, Bintan, Tanjung
Yeah.
Pinang. Okay, Doctor. First, I would like to introduce, although I believe that everybody here is well aware of your track record, but I will introduce you a little bit from your CV. Dr. Ilham Habibi is the Vice Chairman, of the Association of Indonesian Engineers, or as we know, the Perhimpunan Insinyur Indonesia. Dr. Habibi is the Vice Chairman of the Perhimpunan Insinyur Indonesia. Okay, a little bit about his background. Dr. Ilham is the co-founder and the shareholder of PT Iltabi Rekatama, a private investment company in Indonesia. He is also in the One Tiknas and Kadin, Kamar Dagang Indonesia. And we already know that he is the son of the late President, Professor Baharudin Yusuf Habibie. And he holds a Doctor Engineer title in Aeronautical Engineering from the Technical University of Munich, Germany, and MBA from the University of Chicago, USA. Okay, Dr. Ilham, could you please share your presentation?
Thank you very much, dear moderator. I suppose the presentation is with you. Is it correct to assume?
Okay. I don't think we have the slide, but I will check it first.
I can share if needed.
Okay,
I have it in front of me.
You can share your slide.
Yeah, is it okay?
Yeah,
let's check whether the organization has my presentation already. It might have been sent already.
I don't think we have your slide. We haven't got your slide.
Okay, no problem. I share it now. Can you see the first slide?
Okay, Dr. Habibi, we can see your slide. You can begin.
Okay. Well, thanks very much for inviting me to this conference on sustainable engineering development and technological innovation, or ICSEDTI. I don't know how to pronounce this, but ICSEDTI, right? And I'm here presenting, as already announced, in actually more as chair or vice chair of PII, or Persatuan Insinyur Indonesia, or Indonesian Engineers Association. But at the same time, I like to also maybe introduce the National ICT Council, which in fact is a government entity. Okay, so let's start maybe the first part of the presentation. Do you see the second slide already?
Yes, we do. But
okay,
could you please make it full screen?
Oh, okay. How to do this?
If it's possible.
Now?
Okay, that's better. Okay,
so basically, just a small intro about the National ICT Council, or in Indonesian language, Dewan TIK Nasional. It's basically a government entity, sort of like an advisory council, consisting out of members which are truly representing various sectors of our country and society. So usually our society and country is divided into 4 or 5 sectors, such as government, academia, business, and civil society. That will be the quadruple so-called helix. And occasionally also the 5th sector would be the media. So, but in this case, it's just 4 sectors represented in the so-called executive team. You can see it. It's basically government people, And then there is business people like myself. I'm there not as a government person, representing the private sector or the business sector. And then there are universities on the left-hand side, rectors of various universities. And of course, there's also civil society organizations such as Kadin as a Chamber of Commerce and Industry, or MASTA, the Indonesia Telematics Society, etc., etc. So this is the executive team, the working team, and I've had the honor and pleasure.
Okay, I think Dr. Ilham is having a network problem. Okay, ladies and gentlemen, we will wait for a while for Dr. Ilham to reconnect to our network.
What happened? Did you lose me?
Yeah, I think you had a network problem.
I don't think so. I think it's something in between because I was, okay, anyway, I don't mind. So how do I do this now?
Okay, please continue your presentation.
Okay, I just go to the third slide already now. So this is the task of one Tiknas, and I don't want to spend too much time on this because it's not subject of my discussion actually. But the only thing for you to remember is Pan Tiknas is involved in the digital transformation of country. That's it. Okay, so then let's talk about the history of engineers. We know that engineers have always been involved in developing our world, particularly when it comes to solving problems. I remember my late father always told me, Ilham, the difference between scientists and engineers is as such. Scientists look for truth, engineers look for solutions. And so what we know as the world of today in terms of our civilization, all the marvelous achievements, many, not all, but many of those were basically conceived, constructed, and implemented by engineers. And even though some of them might not bear the title of engineers, but what they do is truly engineering work. So basically, it is something that without engineering, I can say that here, among many engineers, I think our work would be a very different one. So in today's challenge is basically another big challenge that we have to overcome. It has to do with energy. So energy needs to be safe, efficient, renewable, and we know why. Because energy is closely related to the climate of our planet. And from scientific analysis, we understand that we need to retain the warming of our planet compared to the so-called pre-industrial period of less of 1.5 degrees. So overall, the warming of the planet compared to the pre-industrial period should not supersede 1.5 degrees. Right now, we are already at 1.3 to the best of my knowledge. So we got to work hard in order to make sure that we don't supersede it. Why? Because that's what the scientists tell us. I had some discussions some time ago in May with a leading climate scientist called Johann Rockström. He works in Germany and he's a Swede. And he was very blunt about this in our discussion that he said, yes, we can, of course, go to a higher warming than 1.5 degrees. But unfortunately, all the models show, because the analysis is done by modeling, of course. And the models are, yes, you can say they're not precise, maybe true, but they're precise enough. I mean, they are already in development since decades. So it's not, you cannot just brush it away and say, oh, this is all hoax. It's not. There's a lot of truth in these models. Yes, there is probably a room for error, but it is also not something you can just do away like that. So the models say that if you supersede 1.5, it's difficult to manage the climate of the planet. That's maybe the best way to say it. It's going to be difficult, not impossible, but very difficult. Before 1.5, I wouldn't say benign, but it's still relatively manageable. Okay, so basically, why PII? So PII is basically the initiator of E20. Right now, Indonesia is the host, the chair of the so-called group of G20 countries, the 20 largest economies in the world. So that's the measure why a country becomes a member and why another does not. It's about the size of the economy. And if you summarize the economic size of those 20 countries, this represents more than 80% of the world in terms of economic contribution, which is also in parallel to other things such as emissions, such as data, etc., etc. So the economy is a pointer, is an indicator for many, many other things, which are very important to understand. And so right now, the three main focus of Indonesia, known to us in the G20 arena, as basically decided by Indonesia as the host of G20 in this year, are the following three. Climate change. Actually, it's not climate change, but what is written in the agreement is it's the transition to renewable energy, which is a foundation for climate change. Then digital transformation, particularly in connect with the economy, and of course healthcare. In that regard, also the global healthcare system that has basically helped all of us to sustain our livelihood despite the pandemic that we were experienced until recently. And in all of this, engineers were important to have their crucial roles in sustaining and improving and even saving lives. And in that regard, we need basically what we define here as so-called leader engineers. Leader engineers are not necessarily engineers leading engineering projects or technical companies, but it's engineers or people with engineering attitude and knowledge. They don't have to be engineers, but they are basically becoming leaders in finding solutions in our many problems that we face on this planet. Some of them are listed here, like environment, human health, etc., etc. And PII is very, very intensively involved in all of this and wants to play a role for us in Indonesia, in this regard, being the initiator for E20 or Engineering 20, and also internationally. E, engineering, but it also stands for energy, I think, because for the current topic, of course, because we have basically agreed among the countries that already have joined the discussion in E20, which is not yet fully recognized by G20 as a sub-organization, but it's in process and it's working with other sub-G20 organizations such as B20, etc., to become more recognized. But the topic that we have agreed on for the coming years, because this is something which will accompany us as a major challenge and problem that we have to face, is basically energy, or I should say renewable energy. So that will be a main focus of E20 in the coming years. So basically, this is the engagement group here. You can see there's a glimpse on what we have done so far. This is basically G20 Summit. On the right-hand side, you see there's two tracks. One is more about finance, and the other one is other ministers such as economy or agriculture, education, etc., etc. And all of that leads to the summit that we will see in Bali from the 15th to 16th of November this year. So in that regard, I think E20 wants to be seen as an engagement group within the structure as shown below here. So let me now jump a little bit. So because the topic is actually not about very generic things, but this is just to introduce myself and PII again in front of all of us. But I want to talk about something that was suggested to me as a topic I should present about in this conference, which is basically what I call as wing in ground effect. And a few basics. Indonesia is indeed the largest archipelagic country that we find in Indonesia, in the world, sorry. This is basically the map of Indonesia. And if you take the most western point, I suppose you can see the cursor, my cursor here, this is Banda Aceh, and connected to this point here, Jayapura or Malacca, this is about 5,500 kilometers, which is actually more than mainland US. So you can imagine in the US, can we imagine the US without a functioning aeronautical infrastructure, meaning without airplanes and airports? Probably not. I mean, it's very difficult to see the US economy, which I think, if I'm not mistaken, has about 1 billion passengers per year at the peak, to function and to blossom and to grow as it does right now without that underlying infrastructure. And infrastructure is, of course, predominantly used by passengers, but also by cargo. Cargo, in some cases, is also used by railroad, which is very important as well in the US, and trucks. But for passengers, if you're talking about longer distances, then in the US, there's actually, of course, a very good toll road system, or not toll, sometimes you don't have to pay for that, but highway system, freeway system, but it's not that complete, so not all cities are connected by that. And so in many instances, and if you fly long or travel longer distances, then the aeronautical component or the aeronautical part of the infrastructure becomes very, very important. So here in this map, you see basically that Indonesia has a similar challenge. In fact, this is not only distance, but the character of our country is archipelagic, meaning we just theoretically, we cannot connect all with bridges and tunnels and roads and railroad tracks. We have to use other means. This is basically maritime and aeronautical means. And even in some cases, if you talk about data, then the space, meaning astronautical, is also becoming quite important for the country of the size of Indonesia. Not many people know that Indonesia as a country is actually the third country in the world that has used satellite technology for telecommunication means domestically. After the US and Canada, Indonesia was the third. That was in the early 70s with the Palapa satellite. And now we have actually connected the whole archipelago with a backbone fiber optic fiber system connecting all large cities with one another, which solves the so-called first mile problem for digital infrastructure. But to get it to the consumer, to the office, to the industry, to the hospital, to the school, university, etc., that's still a challenge. Then we basically, the last mile is not complete yet. Of course, it needs time. It's also a commercial problem and a technical problem, because in some cases, the geography is just not easy to implement anything. Like in the very east here in Papua, you have a very big piece of land and very high mountains, very thick and dense jungle and big rivers. And so it's not easy. But basically to connect that now for people, carrying people and some cargo that needs to be transported in a fast manner, we need to use airplanes. So I'm talking about airplanes here. Air transportation is the best way to connect in some cases. I mentioned that already. Basically, Indonesia is a very fast growing aviation market. It's the data shows that historically it has been the second fastest growing aviation market in the world after China, based on aircraft purchases and trade value. And also, as I said before, we are actually almost destined to be an aeronautical country because of the character of our country being archipelagic. So this is a few numbers that we have here: number of airports, number of operated aircraft, number of flight routes. I think compared to other countries, it's still very small. But for your information, the number of airports, for instance, only about 30 plus are operated as a commercial entity. So most of them are still owned by the ministry or by the government through the Ministry of Transportation. So they are not operated commercially, but they are owned by the ministry or co-owned by the province or by the regency. And so there's still a lot of room for development. So the ones that are functioning very well and they are routinely being a destination, they are just 30 plus, and most of them are owned by the state-owned companies called Angkasa Pura 1 and 2, the airport operator, but Now Indonesia is going more and more into privatization of these airports, but there's not many examples yet. There's only one or two, and they are not in operation yet. So that's about to begin. But my prediction would be, once we have that privatization in full swing, maybe in the so-called public-private partnership, then we see more airports coming up, and then we see also more routes and more aircraft operated. Not all of the aircraft need to be big, but some of them can be very small, like 10 seats, 19 seats, what I would call fall into the category of so-called general aviation. Operated by other operators, not Garuda, but smaller operators, maybe some of them even only regionally or sub-regionally. But that proliferation of air transport in Indonesia will accompany our economic growth and also the development of businesses, not only the big business, but also small and medium-sized enterprises. So, So we have seen the numbers, of course, going down in the last 2 years because of COVID. No need to talk about that. It's logic. Many countries have seen the same thing. So now let's talk about WRG. So I've given you a basic about aeronautics in Indonesia, and I've given you a basic about engineering and a little bit about the ICT sector. But let's talk about WIG. Some people call it, or WIG. Some people call it wing in service effect. And I have to shock you a little bit here. It's actually not an aircraft. I'm very sorry. It's not an aircraft. It is a ship. That's very surprising for some of you. But right now, the concept says basically the following. The airplane in ground effect, as we know it right now, is usually used over water surfaces. And water surfaces connecting harbors or islands or places where you don't have facilities such as an airport. And I'm talking about future talk. This is not in operation yet. But the idea is that it will be used like this. Oh, sorry. This is more like this. So basically, it is something faster than ferries and ships. We don't need infrastructure to lay it down. Water is the runway. It has better harbor maneuvering than ships. And if you use electric propulsion, of course, it is zero emission. And I have to tell you a little bit about technology here, because what is actually the point about wing and ground effect? What is the so-called ground effect? Well, ground effect is something that happens naturally, aerodynamically, wherever we are. The ground, meaning the firm ground, if you imagine the wind blowing over us, if we have wind, then at the ground, the fluid particles, meaning the air, does not move. It sticks, basically, right? So you have this so-called, you call this boundary layer. There's a distribution of wind, basically with increasing velocities, the higher you go from the surface onwards, upwards, not onwards, upwards. So on the surface, on the ground, the boundary condition says there is no wind at all, which is logic. On the ground itself, touching the ground, there's no wind. But the higher you go, the stronger the wind is. So you basically have a distribution of wind speed between the ground itself and a certain height. There's something like what we call a boundary layer. This is 1.1 to imagine, to remember. Point 2 is what actually makes an airplane fly. It's a difference of wind speed, of air speed, I should say, below and above the wing. If you have a higher speed of air above the wing, then Bernoulli, which is a very famous equation, or actually a scientist from Switzerland, says that the static pressure becomes lower because the dynamic pressure is higher. So basically, because of that, you have basically lower static pressure above the wing than below the wing if the velocity of the air above the wing is higher than below the wing. And that is determined by the shape of the wing. And because of the difference in pressure, this wing is lifted up in the direction of the lower pressure, because it's sort of pushed by the higher pressure below the wing. In fact, it's not true to say it's pushed up, it's actually sucked up. because the pressure above the wing is so much smaller than the ambient pressure that the effect is actually more like a sucking the wind up rather than pushing it up. It's a bit hard to imagine, but the truth is it's like that. So now imagine this wing flying in a boundary layer. If it flies in 10,000 meters altitude, you can assume that the wind or the airspeed below and above the wing are the same, right? Because it's the same, no matter, the wing is very thin. But if you fly in a boundary layer, then because of the boundary, of the condition that the wind, that the distribution of the airflow is already different below and in the boundary layer itself, because of the boundary layer, you have basically a plus. You can fly in that boundary layer with a smaller wing, because it is naturally given that the wind speed above the wing is by nature already faster than below the wing. Okay, so just remember that. So if you imagine now this plane to be flying above the boundary layer of a ocean, then the ocean is flat, right? Unless it has some some waves, but it is relatively flat. So you can fly relatively steady and just fly and enjoy the boundary layer effect. That's why wing and ground effect is very much used over the ocean. If you imagine the same thing about the surface of the earth, you have hills and you have mountains and you have buildings. You would, if you want to be steady, like say 10 meters or 5 meters above the ground, the flight will be very unsmooth, will be very disrupted, but you have to go like this, according to the surface of the earth. And so that's why it is actually predominantly used for marine applications. And that's why many wing and ground effect aircraft are not really aircraft, they are ships, flying ships. Just imagine, and so why is it important to understand is because it's now it becomes economic. If we would have to certify the wing according to aeronautic convention, we would have to go to certification agencies such as the most famous two, the Federal Aviation Authority from United States called FAA and the European Airworthiness Authority called Airworthiness and Safety Authority called EASA. These two are the most famous, and to certify an airplane due to their convention and regulation is very, very expensive, very cumbersome, takes many years. To do it through the marine application, or called IMO, International Marine Organization, which is actually headquartered in London, if I'm not mistaken, is much easier. To be a pilot of, on another side, to be a pilot for an airline is very, very restricted and very cumbersome. But if you're a ship, if you fly, you take a boat and you get a license for that, it's not easy as well, but it's easier than to become a pilot. And flying a WIG boat, if I may say so, is actually not rocket science. You have to imagine you speed up, you pull the rudder, and just flies. And in order to land, you just put it on, just lands. It's very easy. That is basically the design. So you have to imagine in a country like Indonesia, how many islands do we have, and how many airports do we have, and how many users of ferries and ships do we have compared to a lot, right? But where is actually the use of a WIG? It must be somewhere in between a ferry and an airport, an airplane. So basically in that regard, the first application that we have, I've actually done some work in this just as an entrepreneur. And that one application that we saw is to help our police and our Coast Guard, and in some instances even our Navy, to chase illegal smugglers, pirates. Yes, we do have those people in Indonesia at some point in time, very active in the state of Malacca, and illegal fishers, because some of them come with very fast boats. And until we detect them and we chase them down, they're gone already. So people were complaining, we need something fast to really chase those people. So you can imagine any fast boat will just lose against the wing and ground effect vehicle. But again, this is not rocket. It's not rocket science to create it either. And now I'll go back one slide. There's basically two schools of thoughts here. which I cannot explain in detail what the difference actually is, but there were two people, one from the Soviet Union, that's why it's not Russia, but USSR. Some of these people are actually not strictly speaking Russian anymore, but they were basically developing the technology in the 50s or 60s of last century. And you see some examples here, how they look like. They look like flying boats, actually, which are, some of them, if you remember the Dornier or there is still flying boats in Indonesia that we see predominantly for firefighting. These are really airplanes. One is the so-called Canadair CL 415 or 215, which is used for firefighting. It's an amazing plane. It's a seaplane that basically ejects a lot of water from its body to extinguish forest fires or peat fires in Indonesia. And when it wants to retank, it doesn't have to land. It just flies above the water, and because of the under pressure below it flies very close to the ground of the water. It sucks the water into the body and doesn't need really to land. It just flies above a lake or about any given surface, which is quiet and nice and smooth, and then fills the tank and flies back to the organization, to the location where it ejects the water and continues to extinguish the fire. That is an airplane. But what I'm talking about is here, these are chronoplanes or ground, etc., etc. I'm almost done. Don't worry. I'm almost done. Yeah. So basically,
we only have 1 minute left.
Yeah, I understand. I just said I'm almost done. So basically, you can see here the plane. It looks a bit different because it's actually a boat. Yeah, it's not optimized to be a plane, but it's optimized to fly in a boundary layer of an ocean, basically. So now the business aviation is usually the driver of innovation. So fuel, of course, is a major component here. And our experience shows that every generation of airplane is always more fuel efficient. But I have to say this number is probably not valid here if we compare with electric, because the 15 to 20% fuel efficiency gain every generation is applicable to one type of engine, which is basically the conventional kerosene consuming engine. But if you do battery electric, it will be very different. Yeah, so we can't really compare. So now talk a little bit about if we can imagine the combination of what I said before of WIG and electric, we can have more short flights, because for very long flights, it's probably not feasible because it's too slow. It's quite slow flying in the boundary layer. It's not comparable with an airplane. But for something which is feasible, we can have more flights and have actually less carbon footprint, not more, as written here, because that is basically valid for commercial planes of the current technology using kerosene. So that is basically WIG or electric. And yes, that was already the last slide that I wanted to present. As promised, it's not going to take a long time. So some more, I mean, this is not typically one thickness presentation, because it's not about ICT that I did just now. But if indeed some of you, ladies and gentlemen, are interested in the ICT sector, then please download our products at this link here. It's all for free, but I think in most instances, unfortunately, it's only in the Indonesian language. I'm sorry for that. So thank you very much for your kind attention. If there's any question, of course, I'm more than happy to try to answer the questions related to WIG or wing and ground effect. Thank you very much.
Okay, thank you very much. A round of applause for Dr. Habibie. Perhaps we could go to the Q&A session with just one question. And we already have I think the rector from Unsil. Okay, doctor, we have a question for you.
Sure.
Right. Assalamualaikum warahmatullahi wabarakatuh. My name is Ari Shahriar. How are you, Mas Irham? Long time no see.
I'm good, thank you. Terima kasih, Mas.
Okay, looking from your presentation just now, surely that according to the economic research, it says that we are going to go into this stagflation era within another 1 or 2 years. How do you look at the business side of not only from your WIG, but also from this, higher, business in airplane? That is first one. The second one is that looking from your your presentation, looking at the using this electric vehicle for airplane or something like that. How do you look at the future generation, because this battery technology is not that mature enough for even for using for the car, and now you are talking about using it in the WIG. I think that's my simple question. Thank you, Mas.
Okay,
Thank you, Mas.
Can answer the question.
Okay, thank you for your very good questions. Number one, stagflation in coming years. I think the question is, how long do we see this period coming, and what should we do in this period of lesser economic activity when it comes to growth-oriented activities? Well, stagflation doesn't mean that we cannot have a business. It means that we have to, usually it means, and it doesn't mean that all businesses are affected by that, but it means that some sectors are more affected than others, and some sectors are still growing, even in the stagflation. I give an example, Mas. Let's talk about data center. Would you say that in this area of stagflation that we see in the coming years, the prospect of establishing data center becomes less? Maybe a little less, but it's still growing, right? So because there's a need for that, which is actually exceeding the need for many other things, people have to maybe look at the economics more in detail, because the buying power of the consumer becomes less. But there is still need, and there is still buying power available. So I think designs in areas such as in the stagflation area needs to be even more economically conscious about the fact that we need to be cost efficient. Yeah, cost efficiency, I think, is a very important factor to be considered in an area like stagflation. And cost conscious is not just using cheaper material or using cheaper manpower when it comes to producing, but it's about the design. I mean, you can do many things with the same quality and the same effectiveness, do it in a cheaper way. So it requires all of us to rethink, to innovate what we're doing conventionally in a different way to do the same or even better in a more cost-efficient way. That would be my answer to you. So that also pertains to a project like WIG. The second is basically about the battery. You're very right, Mas. The battery technology itself has still a long way to go. A long way to go. So for cars, I wouldn't say it's mature, but it's for sure more mature than for other applications such as for airplanes. Now, talking about airplanes, there's only one airplane that I know that's already in use by an airline, which is full electric. Full electric means only battery, and it happens to be a seaplane, and it's used in British Columbia, part of Canada, by an airline called Harbour Airline or Harbour Air, and it's a Beaver. A Beaver, the Havilland Beaver, is a small turboprop or prop airplane. It might use piston engine. I'm not sure about that. And it is traditionally, and it has been the propulsion system has been replaced by full battery, full. So it flies from Vancouver to other destinations, but it's very short flights, maybe 30 minutes or an hour. I'm not sure whether they can fly an hour. So you can see and it's a small plane. You can see the application for batteries, if it's full electric, is still very, very limited. So the current thinking of using batteries in the context of a larger planes, let's say you want to fly an Airbus or a Boeing, is it needs to be hybrid. If you want to use battery, meaning the battery will be used only for certain parts of your flight, like for taxiing when still on the ground, for takeoff, for a certain part of the climb or the descent and the landing and the taxiing again. But for the big chunk, the flight in cruise altitude that can take hours, then you have to switch the battery off and we fly conventionally. So for certain parts, battery, for other parts, not battery. And the parts that are used where the battery is used is basically the parts of the flight which have shorter duration. So why use battery at all? So at least you don't emit carbon dioxide so much if you're close to the ground. And also you can design, once you are already in cruise altitude, meaning at 35,000 feet, you can already, if you switch the engine off, the battery off, you actually you can fly with less power, and also you can fly in some cases with a smaller wing. So basically, it's a different design of plane if you already considered battery from the very beginning. So hybrid is actually only one version. The other version is not battery at all, as we know battery, but it's using hydrogen. So hydrogen can be used either directly as a fuel for an engine, or it can be used in order to fuel a fuel cell, which is sort of like a battery, but a little different concept. We use hydrogen, and the duration of the energy of the fuel cell is longer than a regular battery, because the fuel for the fuel cell is the hydrogen you have on board. So basically, there's another alternative would be sustainable aviation fuel, but it's not at all about battery. This is just the fuel that is used, produced in a different way, that can look at it as something where the carbon dioxide emitted is sort of like balanced by the way the fuel has been generated. Yeah, but it's still disputable whether that really counts at zero emission. So we don't know. So these are the options. But again, if you talk about battery, as we know, a battery like in a car, then the solution would be hybrid. So hybrid electric, partially still conventional, and in certain parts of the flight, the taxiing, the takeoff, the certain parts of climb, certain parts of descent, landing, and taxiing again, that will be then in combination with the conventional propulsion system. Okay, that's my answer. Thank you.
Okay, thank you, Dr. Ilham Habibi. Perhaps this is the end of our session. For Dr. Ilham Habibi, we have
thank you.
A little bit of token of appreciation for you. Perhaps the team will display the award.
Terima kasih. Looks very nice. Is that a sail? Looks like a fire. Yeah. Okay. Thank you very much.
Okay, thank you, Dr. Habibi.
Bye-bye. I say goodbye, yeah? Thank you.
Okay, Doctor.
Or maybe there's a need for making, sometimes there's a need to make a photo, like a joint photo. I'm not sure whether it's necessary. Otherwise, I just say goodbye.
Okay, this one is special. Okay, Doctor, and ladies and gentlemen, I would like to end this session, and thank you for your participation, for the keynote speakers, and I apologize for any shortcomings or mistake. And Assalamualaikum warahmatullahi wabarakatuh. Good.
Waalaikumsalam. Thank you. Terima kasih.
Thank you, Dr. Ilham Habibi.
Bye. Terima kasih.
Terima kasih, Pak. Okay, I will give it back to the MC.
Baik, Bapak Ibu sekalian, berikan tepuk tangan yang meriah untuk moderator kita, Bapak Firman Apriansa. Baik, terima kasih Bapak Ibu sekalian. Dengan demikian usai sudah, ini untuk seminar hari ini, Bapak Ibu, kami sampaikan kepada Bapak Ibu sekalian bahwasanya untuk makan siang nanti bertempat di ruangan ini Bapak Ibu, dan setelah menikmati makan siang, Bapak Ibu nanti untuk parallel session ini akan dilakukan tempat di lantai 3 Gardenia Ballroom Aston Hotel Tanjung Pinang. Sementara untuk kegiatan Musyawarah Nasional Munas FORTEI 2022 bertempat di ruangan ini Bapak Ibu sekalian. Jadi kami sampaikan untuk Bapak Ibu sekalian, untuk parallel session dilaksanakan di lantai 3 Gardenia Ballroom Aston Hotel Tanjung Pinang, dan untuk Musyawarah Nasional Munas FORTEI 2022 bertempat di ruangan ini.
So ladies and gentlemen, we will have a break for lunch and prayer, and will be continued by the parallel session. For the parallel session, will be started at 1 p.m. at the third floor at the Aston Hotel in the Gardenia Ballroom. For all the seminar participants are accepted to attend 15 minutes before the event starts. And for the national conference will be continued in this room. For all of the participants of the national conference are expected to attend 15 minutes before the event starts. So enjoy your lunch and have a nice day. Good afternoon.
Baik Bapak Ibu, kami sampaikan dimohon nanti untuk hadir 15 menit sebelum kegiatan dimulai. Saat ini Bapak Ibu kami persilakan untuk dapat menikmati hidangan yang telah tersedia untuk Bapak Ibu yang ingin melaksanakan ibadah sholat zuhur. Bapak Ibu kami sampaikan bahwasanya musola tersedia di bagian luar lantai 2 gedung TCC, tempat berlangsungnya kegiatan pada hari ini Bapak Ibu sekalian. Kembali kami sampaikan Bapak Ibu yang ingin melaksanakan sholat zuhur, Bapak Ibu bisa menuju ke lantai 2 dari gedung TCC. Terima kasih kami sampaikan kepada Bapak Ibu sekalian.